online education platform for engineering students. Myself, Mallesham Devasane. Here I have started, and including me, other faculty also started the series for making you to practice various subjects in computer science. Today I am going to start a session on practicing on algorithms. You know, we have already completed the C programming, few practicing questions, discrete mathematics, and now even data structure also we have completed. Now we are going to see algorithms. So my aim is to start the various subjects in this session so that you will have a touch to face all the exams that are going to come soon. ISRO, BARC, Triple IT Hyderabad, and all these exams you are going to face soon, and maybe in future the GATE if you are writing for GATE 2022 exam, right? So without wasting the time, let's begin our session. Yeah, if you are not aware about me, yeah, I have more than 12 years of teaching experience, and I have completed Mtech from IIT Bombay. I have guided more than 1 lakh students for a GATE, PSUs, also placements, and I have secured GATE multiple times during my Btech with self-preparation. I have selected for various jobs. Yes. And in case if you are interested to take the Gradeup Super subscription, yes, we are always there to help you. Just call this number 9650052904. Yes, you might have an offer to get a discount on Gradeup Super subscription. So this number will help you a lot. So now we are going to start the algorithmic questions. Yes, in case if you are watching this video, please like the session and also share with your friends and subscribe, guys. Yes, Divya, good evening. Good evening, guys. A very small session where we are going to practice algorithmic questions. Yeah, good evening. Very good evening, guys. Yes, good evening, Sneha. Good evening. Welcome back. Don't forget to like the session, guys. The time taken by a binary search algorithm, time taken by, yes, Nishu, good evening. Got a notification? Great. This is ISRO 2007 question. And look at the time taken by binary search algorithm. That's fine. But what is this? To search a key in sorted array. If you are applying binary search algorithm, is that sorted array, unsorted array? Mostly we use what? The sorted array. Not mostly, all the time. Binary search algorithm we apply on sorted array. So what is the time taken to search an element? Good evening, Rahul. This is a basic question in computer science algorithms. The first when you start algorithms, the searching and sorting are the basics in data structure algorithm. Yeah. Please answer, guys, and also like this session. Good evening, Bharat. A. If this is not there, if this is there, let's say two cases. One, let's say it's sorted. Second, unsorted, means not sorted. Basically, binary search we never apply on unsorted array. Remember that. Binary search we never apply on unsorted array. In case if you want to apply binary search, you can't do it. You have to apply linear search only. So sorted array, no doubt, it is order of log n. Everybody, why is that? If you have an array which is sorted and you will compare with middle element, either left side or right side, you are going to divide an array into a part. So your element might be left side to the middle or right side or maybe middle. If it is a middle, it is a constant time. If it is left side, we take half of the array only. So T of n by 2 plus, to find the middle, we may say plus 1. So this is the recurrence relation for the binary search algorithm. Because always you take either this side or this side. We don't need to sub-arrays. Only we need one of them. So this gives you log n. In case if they ask, these are the big O. In case if they ask, what is the best case, guys? In case if they ask, what is the best case? This is not the best case, that is the worst case. What is the best case? To search a key. What is the best case? Using binary search. This is log n. What is the best case? Quick guys, what is the best case? Analysis. You can search my name on Google. You will find all my details, including mail ID, mobile number, everything. Yes. 9911691155. Middle element is the key. Yes. Order of 1. It's a constant. It's a constant. Yes. Average is also log n. Yeah. Second question. Very easy, I think. And ISRO 2007 again. And that is the difference between GATE and ISRO, guys. ISRO, most of the questions are straightforward. I can say 70% of the questions are straightforward. Those people who answered that 70% of the questions, you can shortlist for an interview. You will be shortlisted for interview. Remember, ISRO questions are straightforward. More than 70%. More than 70%. That's why the cracking ISRO exam, written exam is so easy than the GATE. Have you seen the previous one and this one? Just it's seconds if you have studied this concept. The merge algorithm. Whether it is average or worst, even best, all of them are going to be decided by the same analysis, same algorithm. And T of n is equal to 2 times you are going to apply, that is with order of n, let's say. So if you have an array, you are going to divide into 2 subparts. And you are going to consider both of them, not one of them like a binary search. That was only one of them. You are going to consider both of them, and for the merge, you need order of n in the worst case. So this is the recurrence relation for whether it is best, average, worst, all of them are going to run same. It is order of n log n. If you solve this equation, you will get order of n log n. Right? Yeah, most of you have answered. That is what the ISRO exam, that is what ISRO exam is about. All about, guys. Okay, next one. Again 2007. Look at how easy this question is. How easy this question is, guys. And such questions can help you to crack, to get good marks in ISRO. I am saying 70 to 80% you don't face difficulty in ISRO exam. But 10 to 20% is there difficulty. Selection sort algorithm is going to use which designing strategy? Which comes under what example? Divide and conquer, dynamic programming, greedy, backtracking. Selection, that word says, come on, Divya, selection sort. Are you going to divide an array into 2 parts? No, right? The selection sort, come on. If you have an array of n elements, let's say, Let's say I have something. Let's say I'm going to choose the minimum first. Let's say I'm going to choose who is the first minimum. So I'm going to choose 1, and the 1 I'm going to swap from with this 2. But I need to find first who is the minimum. So you get this is the minimum. Then you are going to get 1 first. Then 1 here. And it is placed. And remaining you are going to apply the selection sort. Let's say 2, 5, 3, 6, 7. And next, who is the second minimum? Second 2 is already stored or placed in right order, which is permitted in right order. And next 3 will be here. Next 5, 6, 7. And what are you trying to do? You are trying to select a minimum. First minimum, second minimum, third minimum. So that is greedy approach. Every time you are choosing the best answer, that is optimum in the final answer. It's a greedy approach. This greedy approach you use in many concepts, like in Kruskal's algorithm, we'll choose the smallest edge, next smallest, third smallest. Did you remember? Did you remember that? Kruskal's algorithm, even Prim's algorithm, even this selection sort also. Like you have so many such algorithms where you apply the greedy concept. Everybody, even fractional knapsack also, but it's not 0-1 knapsack, remember, fractional knapsack also, yeah. Yeah, we'll get another time, same question guys, wait for that. Which one of the following in place sorting algorithms needs minimum number of swaps? Let's see who will answer this. Minimum number of swaps. Where is bubble sort? Out of these 4 options, which is in place sorting algorithms? Come on. Any of heap sort you can ignore that it is. But out of the first 3, which one will have the minimum number of swaps? Okay, forget about in place. Let's find out at least number of swaps. Which is going to be? No. Here you will confuse a lot. Because I didn't ask the time complexity. I didn't ask comparisons. I am asking the swaps. Both are different guys. Number of comparisons different. Number of swaps different. Both questions are different. Number of comparisons, number of swaps, both are different. Yes, Aditya is answering right. In such a quick sort, guys, you know how many swaps? Each time you put a pivot, then worst case, you know that n/2 swaps. Each time, guys, each pass of the algorithm can go n/2. That means if there are n elements, n/2 swaps can be in each time. But insertion sort, it's order of n square, and selection sort, best worst average. In the worst case, this is just order of n. Why? Have you seen just before? First, if you have any array, first we place the first minimum. Then for the first minimum, we'll just swap this position with wherever the first minimum is there. Just before we have seen. Then second minimum we get here, 2 second swap. And oddly, you will see n-1 swaps. In the worst case, you will see n-1 swaps. Here there is no such algorithm in the worst case n-1 swaps, guys. That is a selection sort only. Insertion sort takes less time when already elements are in sorted order. Yes, this insertion sort can do, but if elements are in sorted order. But did I say any sorted order such things? No, right? In general, which in place algorithm needs minimum number of swaps. In the worst case, the selection sort takes n minus 1 swaps, n minus 1 swaps. So this is the best one. Come on, come on. This is the best one. All right. Next one. Yeah, very interesting question, guys. What is the time complexity of following module? I know you are going to do the mistake. In this question, you will do the mistake. Let's see how will you find out. What could be this is the ISRO 2014. And hardly it takes 1 or 2 minutes, those people who knows the algorithmic concepts. How to understand the time complexity of this recurrence relation? No answer yet. See, I thought, Gautami, you will answer. Many people will answer C. Let's see who will answer C. Is that correct? I want you to find out. I want you to find out which is the right approach now. Which is the right approach? Okay. T of n is equal to T of n minus 1 plus n. Another one, T of n is equal to T of n minus 1 plus 1 or C, it is your choice. Out of these two recurrence relations, which one you are going to use? Out of these two, which one you are going to choose? Anonymous. Let's see who will answer that. There are two recurrence relations I have written. Which one you are going to write? Yes, second one, not the first one. That is the return value. That is the return value, not the time complexity. The return value depends on this equation. Yes, n plus n minus 1 plus the return value is, let's say, n square, near to n square. But this is the time complexity. N plus, for this, it takes constant time. And you are going to call T of n minus 1. This one, you are going to use this recurrence relation. The plus 1 is to perform the addition. With the extra term. And this is what you have to choose. This n is not the complexity, guys. N plus means one addition is required. But this is a recursive call. So how much depth you are going to see? T of n minus 1, that will call T of n minus 2 like this. I'm assuming this is a T. Module is a T. T of n will just do T of n minus 1 and will just do T of n minus 2. This is the complexity. But later on adding plus n minus 1, that takes just constant time. But what is the depth of this? Till you get a 1. So this is the time complexity. The depth of the recursion is going to be very important here. Yes, this will give you order of n. So answer is order of n, guys. Clear, everyone? Yes, 1 plus. Yes, you are going to add, but in the written process you are going to add. Here you are going to call the recursion till you get T of 1, then return you are going to do the addition. Alright, that is order of n. This is only what is the return value? The return value depends on n square. Everybody clear? The return value definitely near to n square, but not exactly. I can't say now. Let's look at it is n plus n minus 1 till 1, that is a sigma n into n plus 1 by 2. That is the return value. If anybody asks what is the return value, What is the return value? That is n plus n minus 1 plus till 1, that is n into n plus 1 by 2. That is the return value. Value only, it's not a complexity. Everybody, that is the return value recurrence relation. This is a time complexity recurrence relation. Alright, alright. Clear everyone? First time when I was studying the algorithms, yes, I used to write recurrence relation, but I was not aware, is this time complexity, or is this the number of function calls, or is this return value, and what exactly you are talking about. So you should aware, why are you writing these recursive calls? Because each functionality will have a different recursive equation. This is for the return value, this is for the time complexity. Yes, and this also helps you how many recursive calls you are making here. Yes, this is also going to help you number of recursive calls. Alright, let's go to the next one. Okay, this is another. Yesterday the Bharathendu was asking about it. Now look at this one. Average number of key comparisons. Did you remember Bharathendu, that question you were asking yesterday in one of the question? Average number of key comparisons required for a successful search for a linear or sequential search of n items. Let's see now, what could be the right answer? And don't forget to like the session, guys. Please do that. Yes, Amit. Chandana, right. Santosh, right. And successful search. You need to focus on successful search. Maybe the first search you might be succeeding, or first you might fail. Maybe second you are succeeding. Third element might be. The fourth element might be. If there are n elements, nth element might be success. The success might come from any place. Any element can be your search, right? Your key. If the first is success, that means 1 out of n. Your second is, right, the second element, and this one. Third one, 3 out of n. Fourth one, you need to find out average, right? The probability we are doing it. And if you look at that, the average number of comparisons, if you do that, that is above 1 is sigma n by n. If you do that, n into n plus 1 by 2, and this is sigma n by n, n cancel, so n plus 1 by 2. The average expected number of key comparisons. Everybody? Yes. So C is the right answer. Correct, correct. Everyone? Next. The number of comparisons made in the execution of the loop. Now, maybe it is a wrong question, or maybe it is a wrong options, but you have to assume in ISRO if they have not mentioned clearly. So we will do right answer, but we will assume to get one of the option. So this is the one difficulty you will face in ISRO exam. Sometimes question may not be specified completely, but to get the right answer you need to assume something. Let's say who will assume and who will get the right answer. Here there is no answer, guys. Without assumption you don't get an answer. It's who will assume correctly to get one of the answer. Chandan, think about. take n is equal to, let's say 4, 5, 6, 7 and try it. Give the try. Chandana says A. What about others? Everybody knows about seal and floor? Everybody knows this is the seal function and this is the floor function. A, D, C. Almost all answers we got. We need I comparisons for ith element. Number of comparisons made. Total comparisons we want. Abhinay. C. Is that correct? C. Try guys. Is that correct? C. Okay, let's try one by one. Let's take n is equal to, let's take multiple of 2. I am just taking from 2, 3, 4, 5, 6, 7. For these elements, I will search, I will look at how many comparisons so that I will get to know is that my one of the option will match with all of them. My one of the option will match with all of them. Let's try properly. Let's try properly. When n is equal to 2, when n is equal to, what is the j value is going to be? J will start from 1. When 1 less than or equal to, it's true, it's true. So you will enter. Then 1 into 2, 2 less than or equal to, you will enter again. Then 2 into 2, 4. At 4 you will fail, you will fail. How many comparisons we made guys? How many comparisons we made? How many comparisons we made? Come on, quick. How many comparisons we made for n is equal to? Quick. How many comparisons we made? And that here we have total 3 comparisons. We made 3 comparisons. And for this 3, same 3 lies here. First 3, j is equal to 1, 2 and 4. Here also 3 comparisons. And when we have a 4, how many comparisons? 4. Here for this j starts with 1 and next to 2 and 2 into 2 4, still 4 less than or equal 4, and after that 8 it will fail. So 4 comparisons. 5 also 4 because 5 in between 4 and 8. 6 also 4. 7 also 4. For 8 you will get 9 comparisons. 5 comparisons. Because you need to go to the 16. Here j is equal to 1, 2, 3, 4, 8, 16. You need to have 5 iterations of the loop. Yes, now, is there anybody matching with this option? Let's try. N is equal to 2, 3. N is equal to 3. You should get the answer 3. Who is getting 2 base 2? Let's try from here to here otherwise. Big number 4, 5, 6, 7. Try for 4, 5, 6, 7. 4 base 2 is a 2. 2 plus 1, 3 is coming, but we have a 4. We have a 4. Look at that option. And if it is true, let's see for all of them. 5, 6, 7. If you apply 5 base 2, log 5 base 2, 2 point something, 3 plus 1, you are getting 4. 5 you are getting 4, but 4 you are getting 3 only. So it's not correct. Because 4, 5, 6, 7, you should get same answer. Same answer you should get. Let's see who is giving 4. And this one, n 4, 5, 6, 7, wrong. And this one, 4 base 2, we get only 2. This is also wrong. And this one, 4 base 2 is a 2 plus 1, 3 only. 3 only. But what is the problem here? They did not assume the failed last condition. So this 4, 4, 4, 4, they got the 3, 3, 3, 3 because actual answer is log n base 2 plus 2 plus 1 to enter into the loop plus 1 to fail. So they did not assume the failed termination, the termination of the loop. So they just assumed that this is entry of the loops only. So those statements are those conditions which were true, only they have assumed it. Anyhow, this is what I am talking about. This is what I am talking about. Now look at 4 base 2, 4 base 2, 2 plus 1, 3, 3, and 5 base 2. It's a floor. It's a floor. 2 point something you get 2 only. 2 plus 1, 3, and 6 also. 6 base 2 you will get 2 point. 2 point is 2 only. 2 plus 1, 3 only. 7 base 2 also 2 point something, that is also 2 because of floor. 2 plus 1, 3. And did you see that? Did you see that? D was almost right, but they were ignored this one. But actual answer is plus 1 extra to this. So this is what I am talking about. In ISRO, the questions were framed, but sometimes we don't get the right answer. Either you ignore it or understand which one can match correctly. 4, 5, 6, 7, we want to get a 4, but this is only giving 3. Nobody is giving either 3 or 4, all of them. Only you should realize 4, 5, 6, 7, you should get the equal answer, either 4 or 3. 4 is the right answer, but nobody is giving 4, but this is giving, for all of them is giving 3. Everybody? Yes. Yes. Execution of the loop. In the execution, yeah, this is the loop execution. Whether it is true or false, loop is executing. Remember that. Here, this many true conditions, and this is the false condition. Anyhow, loop is executing. So they might be playing the trick in the execution. So they were assumed true conditions, but don't make English ones. Yes. So don't try to make it correct on your way. Here we have an answer. That's why you are trying to make in the execution of the loop. That means you are going to the inside the loop, not that way. So remember that. All right. I got your intention. Anyhow, the actual answer is log n base 2 floor plus 2. But this is a plus 1. They have assumed only the true conditions of the while loop. All right. Clear? Yes, you can get. Now you understood the point. Now you are making the right answer on your own. Now you are reframing the question. Right. All right. Yeah. Just correct. I'm just already giving an hint why we are failing to answer the question. The reason is there behind. ISRO 2017. Yes, see. Let's see. Don't ever make your concept change based on the answers. First understand the questions clearly, then later on we can make assumptions. The number of swappings needed for the bubble sort. Yes. Let's see how many people can make quickly. You should do in only 1 or 2 minutes, guys. Doesn't matter what is the answer. You should do in 1 or 2 minutes only, or hardly 3 minutes you do it. In ISRO, you don't have much time like a gate. Yeah. Let's see who can do it. Just you have 1 minute or 2 minutes max. How many number of swaps using bubble sort? Everybody knows bubble sort? Yes, got a 10. See that you are able to do in 1 or 2 minutes. Yes, don't assume it is a very big algorithm. It's so easy algorithm. Just you need to play a trick. You will compare this to, but in a sequence we will do till this time. But look at, in a sequence, where did you get the swaps? Mark it. 822 right order, no swap, no swap here. 22 7, yes, you have to do swap. One swap, and 22 goes there. 22 goes there, otherwise you keep on writing it. You keep on writing it immediately. 8, then 7 comes here, and 22 goes here. 9 and 22. There is one more swap. So 9 comes here, but 22 is going further. Remember that. I'm not writing every time like this. 7, 22, and then 9, 22. It takes much time, guys. And no swap now. No swap now. 22, and now 31, 5. Yes, there is a swap. There is a swap. And that you have to realize without cancelling. Without cancelling. And 31, anyhow, it goes last. And 13. So that you can do manually without writing all. See here, how many swaps you got in the first pass? 4 swaps. They might ask in the exam, how many swaps in the first pass? You have 4. Now next, in this, now I will do blindly. Look at that, I will do blindly now. Here I will compare. Here I will compare one swap because 8 is greater than 7. So one swap. And 8 and 9, 8 is there. 8 is there. Remember, here 8 comes, 7 comes. And no swap. And 9, 22, no swap. But 22, 5, yes, swap will be there. 5, 22. Here there is a swap. And 22, 13. 22, 13. Yes, there is a swap. 13, 22. There is a swap and no swap. No swap here. 22, 31. So you got one more. That is 7, 8, 9, 5 and 13, 22, 31. We don't write all this in the exam, just I am explaining in a sequence. Now how many swaps required? In the second pass we got 3. So 4 plus 3 so far. If any mistake, immediately tell me. Yes, the big element, yes. And last, yes, that is not required to compare. Here 31 is already in the swap. And now 22, 22, 31. These are already in the sorted order. Now look at here. 7, 8, no swap. 8, 9, no swap. 9, 5. Yes, there is a swap. And here 5 comes, here 5 comes, here 9 comes. Yes, one swap. And when you compare this to 9 and 13, no swap. So after this you get 7, 8, 5, 9 and 13, 22, 31. And after this till here 31, here 22, now the 13. These are already swapped. Now compare this to, yes, here you have a swap. Here you have a swap. Here you will get 5, here you will get 8. And it's no swap. Now after this, you get 7, 5, 8 and these are already swapped. Now you compare this one, you got a one swap here, you get another swap. After that there are no more swaps because all elements are in sorted order. How many swaps? 1, 2, 3, already 7 here, total 10. Yes, it just take 1 minute if you can understand the algorithm. But in the exam, don't waste time while cancelling all of them. You can believe that what is happening here. Right. So that can be done in just 1 minute. You can do just in 1 minute. Okay, guys. Yeah, very famous algorithm. In most of the written test, this is the most famous algorithm in computer science. I have seen in many interview questions, can you write a algorithm? Can you write an algorithm for one of them here? How many of you know this is nothing but A is equal to A minus B? And this is nothing but B is equal to B minus A. It's not a C program, it is not a C++ at all. It is combined pseudocode. It is not a C code, it is not a C++. Yes. Out of two elements, you are always subtracting bigger element with a smaller element. What do you get at the end? Till you get equal, you keep on doing it. Once you get equal, you terminate it. Find the smaller of two numbers. Let's take one example. 5 and 3. 5 and 3. This is assume A, assume B. And is it going to return 3? No. Gautami, it's not going to return 3. Look at here. 5 not equal to 3. 5 greater than 3. So in A, the 5 minus 3, here it is going to store 2. It's going to store 2. Next 2 comma 3. 2 not equal to 3. Now 2 greater than 3 fails. So it comes here. Now B value is going to update. 3 minus 2. It's going to update as a 1. It's going to update as a 1. This is 1. This is a 1. And now 2 not equal to 1. Now 2 greater than 1. So now A is equal to 2 minus 1. It is going to be 1. Now this time both are equal, so it fails. Now print A. Print A means that is a 1. What is that 1? The 5, 3, why did you get a 1, guys? 5, 3, why did you get a 1? It's not the minimum. It's not the difference. What is it? It is a GCD of 5, 3. GCD of 5, 3. GCD of 5, 3. You take any A comma B which are non-zero positive integers, you will get a GCD number. Yes, it computes the GCD of two numbers, guys. I'm already saying it is one of the very important concept for computer science students. If you are going for written test of the IITs, then you might face the GCD concept, because they have very few questions like sorting questions, GCD, prime, factorial. These questions, among them GCD is too important. Yes, guys. Yeah, very interesting question. ISRO 2020, recent guys, last year question. I can say it's a theoretical mathematics. You don't need even algorithmic knowledge. Of course, you require it, but understand they might be asking about multiplications. You can use mathematical knowledge too. Oh, looks very big. Looks equation. Yeah, dekhe डरते हम, right? Guys, just understand little bit. Yes, if you try it, you will get an answer. If you don't try, you will not get it. That is the problem. What is the answer? Somebody answered. Yes, Amit. Very good in maths. Good. Everything they are giving in the question, just you need to follow them. Just you need to follow them. Just you need to follow them. Everything they are given, just you need to follow them. What is M1? They have given order M1, W rows and X columns. That means W rows and X columns. And what is M2? And X1, X rows and Y columns. This is X cross Y. And what is M3? Y rows and Z columns. Y rows and Z columns. And they are mentioning clearly under what condition will it take less time to compute this one. That is the time computing, that is M1, M2, M3. Both are same multiplications. Is less than M1, M2, M3. They are doing two multiplications. Both are doing same M1, M2, M3 multiplications. They have given it. If you multiply these three, first you are doing M1, M2. Guys, if you are doing M1, M2, how many multiplications required? How many multiplications required for this one? M1, M2, how many multiplications required? Wx, xy. Everybody knows W into X into Y. Yes or no? Yes or no? If you want to multiply this, so that you get this is W cross Y. The order you get M1, M2 order, you will get as W cross Y. But to do this, you need WXY multiplications. Right? And after that, to do this, now WY order with M3, that is YZ. You need WYZ. Everybody? So now total is WXY plus WYZ. This many required. This many required. The first one, this side. And this side, M2, M3 is the first. To do this, XYZ you require. XYZ. But order is XZ. Next, W cross X, X cross Z. Then WXZ. WXZ. So total for this, you need to do XYZ multiplications plus WXZ. And they clearly given this less than this. Clearly given. And just you need to prove this matches with one of them. That is WXY plus WYZ is less than XYZ plus WXZ. What I do is I divide both sides, all of them, with WXYZ. Do it every term. Divide both sides WXYZ. What happens now? Which term will get cancelled? Here WXY, so Z left, and WYZ, X left, and XYZ, W left, and WXZ, Y left. So which one is matching, guys? The 1 by Z plus 1 by X. 1 by Z plus 1 by X less than this is a 1 by W plus 1 by Y. Exactly matching. Yeah. Yeah, divide with WXYZ. Correct. So it's after looking at this problem, oh, is it? But getting that idea is very, very important for you guys. That idea we require. So how will you get that ideas? Only when you spend some time while doing such kind of analysis of algorithms. You know, matrix chain multiplication. If you have already spent the time in the matrix chain multiplication, you feel that whenever you see this depends on multiplications only. So you can directly go to the multiplications, you can do very quickly. Yes, if you are seeing the first time, definitely, I don't think you will think this way. Alright. Yes, those people who are not aware of that, today onwards, the enrollments are started. The actual classes will begin from next Saturday and Sunday. So this is the batch we are starting from March 9. March 9, only enrollments. Actual classes will begin from Saturday and Sunday. The enrollments for the next batch, for this a weekend batch, this is a long regular batch. From March 13, we are going to begin. In case if you have any doubt, you can call to our customer care number 96500529904. Yes. Okay. Let's see the another question, guys. If you want to take the Gradeup Super subscription, yes, please contact us. We will help you to get the subscription so you can enjoy our classes. So we'll take this TIFR question, guys, 2014 question, and read the data. You need to perform DFS, but there are conditions. There is a choice. Sorry, guys. The vertex earlier in the alphabetic order is to be chosen. Prashant, Samantha is good book. Classical Data Structures is a good book for preparing data structure for gate. Algorithms is a Corman. That is a but lengthy book which has so many pages. Prashant. Even I have not completed so far whole book too. So where do you begin? And suppose the number of tree edges, T represent tree edges, B represent back edges, C represent cross edges. Do you know what is tree edge, back edge, cross edge? And where do you begin as per the algorithm? You need to choose the vertex earlier in the alphabet. This is you have to choose. Whenever there is any confusion, you always choose this one. Now, I don't know where to begin. What I do, I apply this condition. So, we will start from A. And DFS, you need to go depth. So, only one way you have a B. And from B, you have only one choice. You have to go to the E. From E, you have only one choice, that is a C. Now, after that, this is called as, what is that? Now, we have only this edge. What is this edge called as? You are pointing to ancestor. This is called as back edge. Anyhow, that edge we will not consider, but we have come to one back edge. Anyhow, we don't consider in the DFS. We ignored it. Now, we need to cover this D. How do you do that? Now, that is only one choice left. You have to choose it. So, I'm going to choose D. I'm choosing it. But now, I have two edges. This edge. Which edge? And this edge. What edge it is? It's called as cross edge. No relation with them. So, it's a cross edge. And this purple edges are called as tree edges. So, three edges and two cross edges and one back edge. So, this is what you have to choose. That is option D. Clear? Yeah, guys, we have a lot of questions, but I have other sessions too. So I'm just believing you are getting good practice on algorithms, but this is not the end. I'm going to come again with algorithm questions later on one day. But my whole intention is to cover all the subjects with few concepts, so that you are not losing any subject for upcoming exams. So this kind of questions analysis is going to help you a lot. So there are a lot of other questions you can practice, right? There is, guys, I have no time, but you can practice them. Yes, I'll come up with these questions again later on. Yes, in case if you need our help, yes, this is the helpline number to contact us, and they will help you. Whatever the problem you have. If you want to prepare with us, you're always welcome, guys. Yes, in case if you are not aware, please know about, there are two batches we are going to start. One is weekend, one is weekdays. Yes, and please take enrollment as soon as possible. In computer science, we have very good experts and everybody has a very good experience, right? Yeah. Connected component will give tree edges. Exactly, Bharatendu. Yes. Yes, these are the top educators, and Satish sir also joined. I missed his slide. Yes. Yeah, grade up. सही prep है तो life भी set है. So please practice type wise questions, topic wise quizzes, and where you have lot of questions from the topic wise, and keep attending our live classes. You will learn a lot from us, and thank you so much for joining this session. Don't forget to rate us on Google Play if you are learning from us. Yes, thank you so much, and refer your friends. If anybody want to take the Gradeup Super subscription, yes, you are welcome. And I think at 6 p.m. we have one more session, how to secure the top 100 rank. So that is on Gradeup app. So if you want to attend that class, please come to the Gradeup app. We are going to run one class from 6 p.m. guys. See you then. Take care. And don't forget to like the session, guys.